everyone. In this lesson, we are going to discuss units of temperature. In Math 10-3, we will discuss two SI units of temperature. They are degrees Celsius and Kelvin. So Kelvin is the base unit of temperature, but Celsius is more commonly used day to day in Canada. So let's start talking about Celsius first. Okay, so on the screen right now, I have a Celsius Fahrenheit scale. We won't talk about Fahrenheit at all in this module, but we will in the next module. So we can just ignore that right side. So this is the scale that we are very familiar with. Okay, and some of the common temperatures that we may be aware of are the boiling point of water. So water boils at 100 degrees Celsius, and the temperature at which ice melts is close to 0 degrees Celsius. We also consider this temperature to be the freezing point of water. So when we go from water to ice, or ice melts and turns into water. So it's around that temperature. Now, how did the Celsius scale, how was it created? Who devised it? So a scientist by the name of Anders Celsius actually devised this. And he created something similar to the scale that we have today. It's not exactly it, but basically what he did is he noted the temperature of water at which it boiled, and then the temperature at which water freezes. And when he noted those two temperatures, he divided that distance by 100. So he created 100 degrees, 100 steps between the freezing point of water and the boiling point of water. Okay, so that scale got adapted into the scale that we're using today. So now let's do a short, brief activity. We're going to try to match some common events on the left-hand side with their approximate temperatures on the scale. And this is just to help us visualize or try to, learn some benchmarks to help us understand what different temperatures may feel like. So if you'd like, you can pause this video and try it by yourself, and then play again to check your answers. All right, so let's begin. So let's have a look at the temperatures that we have to match into. So we have -40, -20, and 0. So these are below freezing, and 0 is the freezing point of water. And then we have 10 degrees, 30. This is about 36, 37 maybe, and then 100. So the first one we need to match is the freezing point of water. So this one is definitely 0 degrees. So I'm going to put A here. And B says plug-in car's block heater. So that should be around -20. That is the recommended temperature so that your car doesn't die. A hot summer day. So I'm assuming that's somewhere in the 30s. So it could be 30 degrees or 37. We don't know yet. So let's keep going. Body temperature. Okay, here we go. So the body's temperature is around 37 degrees. So this is going to be D, and then a hot summer day is going to be C. So these are done. Exposed flesh freezes quickly. So that's going to be -40. Water boils. So the boiling point of water is 100 degrees. And then the last one is pleasant spring day. So that is 10 degrees Celsius. So yeah, so this is the matching activity. There's a similar question to this in your module assignment. So you can solve it the same or a similar way to this. So now we're going to move on to temperature problems, and we're going to focus on two types of problems. The first one is how to calculate temperature differences, and the second type of problem is how to calculate average temperatures. So let's start with the first example, calculating temperature differences. What I'd like you to remember is that the word difference is a key word in mathematics, and most of the time, usually it signifies subtraction. So wherever you see that word, if you're asked to calculate a difference, it means you will have to subtract. So let's read example number 1. The coldest recorded temperature in Canada is -63 degrees Celsius. This temperature was recorded on February 3rd, 1947 at Snag, Yukon. The hottest recorded temperature was 45 degrees Celsius on July 5th, 1947, at Middale and Yellowgrass, Saskatchewan. What is the difference between the two temperatures? So here's that keyword, and this means that we will have to subtract. So the first thing that we want to do is we want to try to visualize what this scale looks like. So I'm going to draw or attempt to draw a temperature scale. Okay, I know 0 is somewhere around here. Okay, and the first temperature I have is 45. So let's say this is 10, 20, 30, 40, and then here's 45 right there. And then I have negative 10, negative 20, negative 30, negative 40, negative 50, negative 60. So negative 63 is somewhere around here. So what we want to know is how many degrees are between these two temperatures. How many degrees are between negative 63 degrees and positive 45 degrees. Okay? So to do that, we have to subtract. So I'm just going to erase this for us. And I'm going to move the screen down. So what we're going to do is we're going to go 45 degrees minus negative 63 degrees. Now, because we have two negatives, or a subtraction and a negative, we like to put this in brackets. And now we can calculate this using our calculator. So this gives us 108. And of course, we should always write the units. 108 degrees Celsius. It means between negative 63 degrees and 45 degrees, there are 108 degrees. So let's look at this thermometer here. This is a lot better than the one that I drew. So if you were to count all the degrees in here, okay, you would get 108. Okay. Now, what if we went negative 63 degrees minus 45? What would happen? Well, our answer would be negative 108 degrees. Now, in this particular case, when we're calculating temperature differences, I don't want you to worry too much about the sign, as long as you explain your answer correctly. So there are two ways to explain your answer. You can say that 45 degrees Celsius is 108 degrees Celsius warmer than negative 63 degrees Celsius. So this is one way to explain your answer. Another way is to say that negative 63 degrees Celsius is 108 degrees Celsius colder than 45 degrees Celsius. So both are acceptable. As long as you explain your answer this way, you don't have to worry too much about the positive and the negative. Okay? So don't worry about the order in this particular case. All right, so this is my example illustrating how to calculate temperature differences. Now let's look at an example where we have to calculate a temperature average. Now, by definition, an average is the central point between two values, or between, if you have, for example, several numbers like 5, 3, 4.5, 2. If you find the average, we want to know what is a central number in which all these numbers are around. Okay, so in this case, if we have the number 2, the number 3, 4.5, and 5, this is around that central point. It's somewhere in the middle. So the average would be somewhere around here. Okay, so this is what we're looking for. We're looking for that central value, that central temperature. Okay, so let's have a look at this example here. One day last spring, Esther recorded the maximum highest temperature on her farm. The maximum temperature was positive 13 degrees Celsius. The minimum lowest temperature was negative 7 degrees Celsius. What was the average temperature that day? So let's try to calculate the average here. I'm going to show you how to do that using two methods. So first, what we can do is we can sketch the temperature scale. Now, I have one illustrated on the screen here. This is from your lesson book, but I'm also going to create my own, and I'm going to use a lot of detail here. Okay, so the first thing I'm going to do is I'm going to draw 0, and then I'm going to try to be as detailed as possible, and I'm actually going to draw the first temperature, which is 13 degrees above 0, and I'm going to draw every single line. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, then I'm going to draw -7, so that's 7 below 0. 1, 2, 3, 4, 5, 6, and here is -7. Okay, so what we want to do is we want to find that central value. So we know it's going to be somewhere in the middle. We know it's going to be somewhere around here. So you can actually go ahead and estimate it first before you calculate it. Okay, so how do I know where that middle value is? You can just count, right? I know that from 0 to 13, there's 13 numbers. And from here to here, there are 7 numbers. So 7 plus 13, that gives me 20 numbers, right? So from here to here, there are 20 numbers. What is half of 20? What's in the middle? That's 10. Okay, so what I'm going to do is I'm going to count 10 below 13. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's this point right here. And I'm just going to draw a dot on it. There it is. Okay. Now, you could have also counted 10 from -7, right? So I could have gone, okay, here's -7. I'm going to count 10 because this distance is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here we go. It doesn't matter because it's in the middle. So now that I've figured out where that middle point is, I just have to figure out what that temperature is. So here's 0 degrees. Here's the temperature that is the average or the middle. So it's 1, 2, 3. This is 3 degrees. So the average temperature was 3 degrees Celsius. Okay, so this is one way to do it, is by counting. Another method is by using the formula. So I'm going to solve the same question using this formula. It says average temperature is equal to the maximum temperature plus the minimum temperature. So you add those two together first, and then you divide by 2. Okay, what I'd like you to be careful about here is that in this case, when we're calculating averages, the negatives, they matter. Okay, so we have to make sure that we don't get rid of any negatives like we did in the difference question. So we're going to calculate the average between 13 degrees Celsius and -7 degrees Celsius. So let's first write what we know. Okay, what is the maximum temperature? In this case, that would be 13 degrees Celsius. Okay, what is the minimum temperature? That is -7 degrees Celsius. So now the formula says to find the average, I'm going to use AVG to represent average. That is maximum plus minimum divided by 2. So the average is going to be, the maximum is 13 plus -7 divided by 2. Now do this in steps. Do this first and get a number, and then we're going to solve the fraction. So 13 plus -7 is equal to +6. Then we have that 2. Now fractions in math, this means division. So we're going to go 6 divided by 2, +6 divided by 2. And that gives us +3. So the average temperature is +3 degrees Celsius, which is the exact same answer we got using method 1. So it's around here. Okay? So this is how we calculate average temperatures. So now what we're going to do is we're going to practice. So here's one way that we can do this. You can just watch me solve the questions right now. Or if you'd like, you can pause the video, write the question down and solve it by yourself. And then when you're ready, hit play to watch me go over the question so you can check your answers. Okay, so now I'm going to go over this question here. It says the temperature forecast for May 8th, 2010 in Prince George, BC gives a maximum temperature of 14 degrees Celsius and a minimum temperature of -2 degrees Celsius. So question A is asking us to find the temperature difference. So difference means subtraction, okay? So I'm going to subtract both temperatures so I can see how many degrees are between -2 and 14. And it doesn't ask you for a visual, but I'm going to draw one anyways. So here's 0 degrees, and I'm going to count 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Here it is. This is 14 degrees Celsius. And I'm going to count 2 below 0. So this is -2 degrees Celsius. So what we want to know is how many degrees are between 14 and -2. So we said that we subtract them. So I'm going to go 14 minus -2, and that gives me 16 degrees Celsius. So the temperature difference is 16 degrees. Okay. Now you could have also gone -2 minus 14, but that would have given you -16 degrees Celsius, which is okay, as long as you explain your answer properly, or clearly, I should say. So to conclude this question, I'm going to say that -2 degrees Celsius is 16 degrees Celsius colder than 14 degrees, or you can say 14 degrees Celsius is 16 degrees Celsius warmer than -2 degrees Celsius. All done. All right, now let's answer the next and last question. What is the average temperature in this case? So we can use our formula, which is average is equal to the maximum temperature plus minimum temperature divided by 2. Our maximum temperature in this question is 14 degrees Celsius, and our minimum or lowest temperature is -2 degrees Celsius. So let's substitute into our formula. Maximum is 14, minimum is -2, and then we divide by 2. So 14 plus -2, you can use your calculator, is 12, and then we divide by 2. So this means 12 divided by 2, that is 6. So our average temperature is positive 16 degrees Celsius. Now, positive 6 degrees Celsius. Now, we could have also drawn this. So let's do it by using the counting method. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, and then here we have 2, okay? So we said that there are 16 degrees from here to here. We found that from the first question, right? From question A. So where's the halfway point if there are 16 degrees? Well, the halfway point is at 8, right? So the halfway point is at 8 degrees. So here, from here to here, this is 8 degrees, and from here to here, this is 8 degrees. So to find the average, we're going to just count down by 8. So 1, 2, 3, 4, 5, 6, 7, 8. Here's the average. So what is that temperature? Well, let's count it from 0, right? Here's 0. 1, 2, 3, 4, 5, 6. The average is 6 degrees. Okay? So this is how we use temperature scales to calculate temperature differences and average temperatures.